Welcome to Defender Fridays. As you know, this is our weekly get together to just bring like-minded folks that are looking to kind of raise their collective skill set, their knowledge, some networking, right, and all that good stuff. And as you know, we strive to bring on awesome industry folks that know a thing or two about, the subject matter that we're all interested in. And wow, today we kind of knocked it out of the park, if I can say so myself. Our guest today, I'm really stoked to introduce, is HD Moore. HD is the CEO and founder of runZero, which I'm sure he's going to mention a little bit about what what runZero is up to, but it's a pretty cutting edge sort of network discovery kind of. That's kind of what it started as. I know it does a lot more today. I'll let HD talk about that some, but for those of you that don't know, HD's got really long and deep roots in InfoSec. He's done a lot on the offensive side, and I think probably one of his most well-known contributions to the space is he is the creator of the Metasploit framework, which is like jaw-dropping, like the impact that that's made on red teams and offensive operations, and of course that sword cuts both ways, right? Adversarial operations as well. But an incredible contribution to the space. And so HD, I mean, I know that you've made just decades of impacts here. So thank you so much for taking the time to join us on our weekly webinar here. And would love to kind of foster kind of a bidirectionality and a collaborative sort of conversation here, because I know a lot of folks would love to kind of pick your brain on all the awesome stuff that you do and know. But yeah, without further ado, welcome HD. Thanks for joining us.
Appreciate it. Thanks, Eric. I've got a couple slides and a little quick demo if you want to see that, or we can just kind of keep it informal, anything in between.
Super informal, fireside chat. Yeah, but all good. If you want to show off anything as well, that's fine too. Just let me know. I can give you screen share.
Okay. Yeah, I've got kind of this thing's been bothering me for like 30 years. So I've been just picking away at this one little problem. And you know how it is. You get like some tactical bug under your skin, and you just can't let it go. So for years now, I've been working on like, how do you identify devices that are on multiple networks at once and that are accidentally bridging multiple systems together? And so it's a combination of like, how do you identify systems that are multi-homed, and then how do you identify the network paths between those machines, basically. I've been calling this recently the kind of like decay of segmentation. We've really used segmentation as such a band-aid for so many problems that when it starts to fall apart, it doesn't really help anybody. Like all your security starts to go by the wayside. These are all techniques that I've used a ton during pen tests, especially for PCI audits, where your goal number one is to get into the card data holder environment. Finding that access and getting in is trivial with these type of techniques, and a real pain otherwise. So yeah, I'd love to pop up maybe a couple slides real quick and to show you kind of what I've been showing on for a bit.
You bet. Here, hang tight, and that's coming your way.
Great, thank you. And I'm going to go real fast because the point, of course, is to be interactive, not demo. But let's say you take your very basic model of what a segmented network looked like 10 years ago. You got your happy little firewall, your happy little DMZ. Down to the right, you've got maybe your guest devices, your printers, your Wi-Fi, the junk you don't care too much about. And over to the left, you get your standard corporate wired stuff that probably shouldn't be exposed to your guest wireless network. And that was kind of how we really looked at the segmentation, even as early as 10 years back. These days, of course, it's gotten a lot more complicated with micro-segmentation, all sorts of fun, fancy VLAN overlays, but that's generally the idea. So the problem is the network diagrams you're getting from IT never really match reality. And each time you have an unexpected link between two segments, it just undermines the entire security for segmentation. But finding those gaps has been super difficult. So I've been spending at least 18 years on it. The first thing I posted was back in 2005 in full disclosure, which was like, how do you use spray packets from a spoofed external IP on an internal network to internal nodes, cause them to basically bounce a response back out their default gateway, it may not be the gateway you know about, to find egress points, even for multiple hops away. And using similar techniques in the tactical implementation talks, it's baked into Metasploit. I've got some tools for finding multi-homed assets through like NetBIOS, SNMP, and my GitHub. And then, runZero, of course, where we do network discovery all day long, in addition to like asset inventory and all the fun CASM bits. That's been kind of a mainstay. So, the challenge is a multi-home machine is any system with more than one address or more than one connection. And effectively, that's everything. I mean, your watch, your phone, your laptop, you get a brand new Mac OS machine and type ifconfig, you're going to see like 19 interfaces. You're going to be like, what the hell is a wireless link display? Why do I have a PAN interface? What is this other thing? Like, those are all almost always routable IP interfaces too. And so you buy a brand new printer, you may not use the wireless on it, but it's using you. Like, it's still connected to your device, which is connected to your wired network, which also has Bluetooth enabled half the time. So you're just seeing these combinations of devices where they're being deployed with multiple interfaces. You don't really have any control over all the traffic that's being routed between them, but you assume it's just, oh, it's just one thing plugged in, and it's really not. So if you look at like segmentation as a key security control, it's basically the basis of everything. If you look at how PCI defines the security model, it's really wrapped around segmentation. You look at the assume breach, the zero trust models, there's a lot of like segmentation gets applied to things you can't do something else with. So if you can't put a ZTNA agent on all these devices, these types of equipment or these machines, well, you have to segment them. So segmentation became our band-aid for literally every security problem that we can't solve through a direct impact to the system itself through an agent of some sort. And it's all kind of falling apart. So here's kind of that same diagram before, but showing kind of all those different gaps where things are really being bridged between them. And these aren't like fake examples. This is my home network right now. I'm using this MacBook. It's plugged into a wired network card, a nice 10 gigabits, and it's also on my Wi-Fi network, which is exposed to all my guest users. It also happens that I'm running some container tooling on it. And guess what container tooling does? Well, it enables IP40. So now I've turned my laptop into a router between my guest network and my core network. And that's normal. That's the default. If you have a MacBook and you connect to Wi-Fi and you connect to Ethernet, the little Wi-Fi link will like disappear and show you being connected to Ethernet. You're still on the Wi-Fi. Same with Windows. Like, so those links don't go away. The OS vendors make it really difficult to know that's happening. Separately, we've got a little printer over here on, let's see, go back a little bit, on the right side. And while it's wired, it's a little brother printer. It's super boring. It's plugged into my wired network. The darn thing keeps resetting its wireless access. Now, anyone who can log into it can get anywhere near my driveway, can just like hop on my printer and from there start like throwing traffic through it to my home network. I can't figure out how to turn off the Wi-Fi in this thing. You can disable the SSID, but it doesn't actually help. So I've got this perfect little printer backdoor.
You tried wrapping it up in aluminum foil.
That would work, yeah. But that's kind of where we're at. I mean, the thing is, like everything these days is like a router. And I'm jumping around a little bit here, but we looked at part of the runZero tooling is we send a IP40 kind of trace, if you will, through every locally scanned asset in any segment of our customer environment. And so we scan everything: light switches, power meters, backnet devices, smart TVs, you name it. And we found like way more stuff is acting as a router than you think it would. Every printer, every NAS, all these V6 enablements. And all you need is one broken segmentation piece for everything to start falling apart. And you start looking at bigger networks. I mean, the segmentation problem is massive. There's just no way you're going to catch every one of these links everywhere. We start getting to networks at scale, it gets obscene super quick.
So just you're talking about they're literally set up for routing here. That yes. If you send destination IP not to them in another subnet, it'll happily route it along as if it were IP40. I mean, it is IP40 enabled. It's not a compromised machine like interpreter routing. Yep.
This isn't, you don't have to pivot, you don't have to exploit it. You literally just point a packet at it and go. And the great thing is also bypasses your layer 2 port NACs. All your NAC is broken too, because I can be in the same segment as your printer. I don't even have to clone your printer's MAC. I just set it as my router and I'm done. And you solve that problem because you're still stealing the device's MAC. So, we did it. Here's just a quick local network with runZero. It's only about, I think, 99 devices are in this. There it goes. I think it's 99 devices in this segment. You do a search for like what has 40 enabled, 25% or 24 of them. Like a quarter of all the devices in this network are routers. And here's some examples. Like your router, you expect that. My OpenSense box, yeah, that makes sense. My Tesla, did not expect my Tesla to be a router, but it is. It'll just route packets all day long. It'll also route packets to its internal Tesla network from my house. So it goes both ways. We're all just sharing.
Your Tesla is also set up to automatically like all of Elon's tweets.
I'm sure that's what they do automatically. It's probably a feature you have to, and I'm sure you have to pay for it too. But your Apple TVs, your little Apple homes, your ADUs, your Synology DSMs, just about everything is acting as a router in some form. Some of these are more expected. Obviously, like what's kind of funny is Proxmox. You wouldn't expect it to be a router, but of course it's a router, right? It's a virtualization stack. So of course it has to have IP40 turned on too. And the second you install Docker tooling on your environment, like your machine is now also a router because it turns on IP40 to be able to route between all your virtual interfaces. So that's kind of the spiel. Is just that like there's a ton of this stuff. I can give you a quick demo if you really want to see me bounce a packet through my printer, but it's not very exciting. It's like a ping command that happens to work even when you change the route. But that's the world. It's everything's a router and segmentation is broken and we're all screwed.
I mean, HD, is this problem sort of amplified, or at least a component of the issue that like a lot of these components, like running hypervisor software on my workstation or Docker containers, basically also turns my system into a NAT device, right? So I can NAT traffic from my workstation. So it's coming from my IP, but my host is not the true source, right? It's actually being NATed through my host. So you might actually have other systems coming through what looks to be a single system, right? Same concept. It's a router, right? It's NATing, But it's tricky, right? Because like, how do you get visibility into that? If you're just looking at network data, it all just looks like it's coming from that one system. You don't see the pre-NAT traffic that's originating within the containers of the VMs, right?
Yeah, and the challenge in that too is it often rewrites things like TCP window sizes. So even if you're using like your fancy network fingerprinting to determine with your NDR, is this a Linux or Windows machine based on the packet sizes, it's still going to look like the Linux firewall's TCP window size, not your OS window.
HD, your name is in fact HD Moore. So have you scanned the internet yet to find how many private networks are exposed this way by public-facing services?
Yeah, I can show you a kind of different approach to it. So for the forwarding test, you actually have to be on the same physical network to be able to send it. However,
broadcast domain?
Yeah, same broadcast domain to be able to get the packet to the MAC address. But if we take the same approaches we do for like internal IP addresses, and let's say throw it at the entire country of Belarus, which we do for fun, because why not? So you can see here on the left side that all these machines already have multiple IPs. So we can detect the same asset as IPs, internal, external, whatever, all across the board. So we just search for like, has private IP in Belarus. These are external facing scans, no authentication, anything like that. Let's see, we've got about, how many assets do we have here? 414,000 in Belarus right now. Let's search for how many of them have private IPs exposed to the internet. 2,273. It's not too much, I guess. But if you go about
2,200 potentially separate internal networks exposed, like that could be 2,200 organizations. It's like finding 2,200 domain controllers. Sure, but it might be 2,200 organizations.
Every one of those green circles is an internal network we found externally. So I think we can hopefully zoom in a little bit.
Everybody on the call is saying, "Oh no, is one of those mine?"
Yeah, the funny thing of this, so if you want to say like I want to hack one particular internal network, you can say like I want to go into 192.168, I don't know, like 30.0/24, and then drill down to all the ones connected into that, and you can find all the different external paths into those internal systems. And we just use a million different protocol tricks to get that stuff out. But I mean, that's the thing; that's normal, and you see the same type of data internal at large enterprises. Like they may think they've got multiple networks highlighted, but all it takes is one dev laptop or one crappy printer in the corner to break it all.
So is it?
Go ahead. Yeah.
Is it best practice now to have your runZero scanner in every broadcast domain effectively? Like give it an IP in every VLAN you can reach?
It's handy. I mean, if you can get away with it, great. I mean, it's lightweight, but if you can't, it's fine too. We have folks who do centralized scanning where they have 1 or 2 explorers to scan like a huge enterprise. Other folks who have like 200 or 300 explorers in every physical store. A lot of retail will have the same IP footprint in every physical store, so you can't really route traffic across it because you can't scan from the same 192 network to the same 192 network someplace else. So you have to be able to put them in different sites, do different explorers for that stuff. But lots of ways you can slice and dice it. I think on average, customers have between like 3 and 5 explorers, even for big orgs, and then really big orgs with tons of segmentation, like talking millions and millions of assets, have like 30 or 40. So it doesn't get too extreme unless you've got a lot of really isolated small sites.
HD, I'm curious if you've, I imagine you probably have you seen any situations where technologies like zero tier or tail scale are being used? Because like that opens up a whole other world of possibilities, because now I can have an additional interface that could potentially be an exit node for an entire other network, right? Of other peer-to-peer meshed VPN systems, right? Like things get a little wild there, huh?
I love it. Yeah. I mean, Tailscale is yet another overlay network, right? I think one of the fun examples I saw yesterday, I'm trying to remember the name of it offhand, it was on like Hacker News, the Orange site. There was a Linux VM or VM-like thing that boots up in your web browser through WASM, creates an entire Linux VM, and then you connect it to the internet through Tailscale. So now you're actually talking to a Linux VM, if you will, running in some person's browser over the Tailscale network. So it's talking about a weird filtering, right?
Oh man, that's wild. So I mean, okay, let's zoom out a little bit here. That was like an incredible adventure through some trenches there. So is this a problem that folks can even really get their arms around, or is it something kind of like vulnerable drivers, where it's like, dude, they're everywhere. There's very little you can do about it. All you can really do is look for the downstream signs of it becoming abused, right? Like, what can folks do? Like, just your everyday IT and security teams, what can they do to start to get their arms around this?
Well, there's a great music video by Javad Malik about accepting the risk. That's one way to do it. Definitely recommend that. But another option, of course, is there's only a few networks you really care about, right? So you're usually doing segmentation to keep bad things from spilling over in other domains. But there's usually only a few that are going to get you fired if something terrible happens. So if you're subject to PCI, the CD has to be locked down all day long. it's not that difficult to set up a like recurring, scan, test, whatever network monitor, and say if I ever find any machine outside my CDE with a CDE IP address on it, like burn it with fire that minute, and just turn that into a fire drill. Like any laptop shows up and it's also my SolarWinds box is multi-home and it has an IP over here too. Get that thing off the network now. One of the biggest drivers for that problem though is actually cost. A lot of vendors will charge based on the number of installs for their product. It's one of the reasons like why we don't at runZero. You get as many installs as you want. We don't care. You just pay by license or asset count. But for folks who charge by seat, or by install, like SolarWinds, the network team doesn't want to buy 2 or 3 servers. They want to set up one server. And the only way to reach one server from everything is to put it into your most dangerous place and then put all your credentials on it and then let the hackers in. So that was a very common way to break into stuff when I was doing a lot of pen tests for PCI organizations is find the SolarWinds box because once you get into that, now you have the admin credentials to reconfigure the ASA and just cut a hole in the firewall. You don't need to bounce through it.
All right. You're starting to creep into the nightmares of probably half our folks here. So yes, exactly that. Wow, I don't think we've ever covered so much content in such a short period of time. We're only halfway through this thing. So well, I'd love to hear from some more folks on the attendee list. I mean, if anybody's got questions, now's your chance to bend this guy's mind. And while we queue up any thoughts or questions, HD. So obviously, one of the things we try not to do on Defender Fridays is do any egregious product pitches, but obviously runZero is designed to do this and so much more. So like, you might just give me a couple quick bullet points. Like, what are some of the things that folks could use runZero for to gain visibility and that kind of thing?
Sure. Yeah, I mean, the one runZero is free. So feel free to set it up, play with your house. You get 100 assets for free, including all our functionality. That's our passive discovery. That's our active scanners. That's all our integrations. You could connect your tenable scanners, whatever you want to it. So we have a free version. You can sign up for the trial, go straight to a free version afterwards. And we've got about 30,000 people who do that all day long, which is great. And also helps us fingerprint stuff because you buy a cool doodad from China and you want to tell us what it is. Great, do a little submit fingerprint, and then we know how to know what it is better. But in general, we mostly sell to like large businesses who are trying to keep track of what they have and where their exposures are. So the idea is that you'd deploy runZero, you deploy what we call our explorers, which are kind of a light, 100 megabyte binary that can do passive discovery, active scanning, and connectors from wherever that point of presence is. And then you quickly find all your stuff. And you start getting a handle on like what's missing from my vulnerability management scope, what's missing from my EDR scope. You start finding kind of all those gaps between overlap of your security controls.
Can I run that miner, that collector? Can I run that in a Docker container on my Synology NAS, which is also a router?
Yes, as long as the Synology will work. You don't want to deploy it in a Docker container that puts you in a NAT networking environment. Otherwise, your raw packet stuff won't transfer. So some Docker containers are like TCP proxies. Basically, those don't work well. One that's a really fun use case that a customer pointed us to is the Cisco ISR routers that run the Cisco IOX stack. It's effectively like a Cisco variant of Docker container you can deploy directly under a router. You can stick the runZero binding directly on those things as is. You just package it up and off it goes, and you've got runZero running directly on your Cisco routers, and it works fine.
Really, that's super cool. Way cool. I know a handful of folks, probably myself included, are probably going to rewatch this one on like 0.7 speed. I mean, I talk fast.
I like coffee.
You're good, man. You're good. You're super good.
Out of curiosity, HD, do you want to speak to a couple of the protocols you're using to do this discovery? You're not literally just attempting to route to each of the networks through it, though that's part of it. But there's also some other protocols that you're using.
Oh yeah,
to specialize in. Yeah.
There's so much cool stuff. So like just a couple of the ways that we can get like the I'll take an easy one. So a lot of folks know that through the NetBIOS UDP protocol, you can ask for a machine what its name is. Say, hey machine, what's your host name? It comes back and say, my name is server 01, right? If you get the response back and then you say, hey server 01, tell me your addresses, it'll actually come back, give you a list of all its IPv4 addresses too, through the same protocol, unauthenticated. And somehow no one knows this still. It's been 20 years of me abusing the hell out of this, and it's in Metasploit, but it's just a really underused feature. You can do something really similar through the DC RPC endpoint mapper and port 135 TCP. You can dump all your programs, but you can also call the Octa2 resolver, which returns all the interfaces of the machine, including the v6 interfaces and the host name. So if you're trying to find machines that are accidentally Choritoed onto the internet through v6, as long as you can talk to 135 TCP, you can get the list of the v6 addresses, figure out whether those are externally exposed. But it's really common for customers to accidentally v6 expose all their internal workstations because they have an Anycast v6 tunnel router from their ISP. So we had a couple university customers reach out saying, hey, our ISP accidentally backdoored our internal network by advertising this route, and now all of our machines are directly exposed via v6, and Shadow Server called us, and now we're in trouble.
There's also the easy stuff, like show of hands, how many people have run IP tables before? How many show of hands, how many people have run IP6 tables before ever in your life?
Right.
Because the same protocol is available over v6 and v4, and there's plenty of environments where, oops, we forgot to block down the v6 version.
Yeah,
so
that's one thing we did.
Really being able to find the v6 IP for the same box is pretty damn useful.
If we scan a v4 network and runZero, we automatically scan v6 and don't even bother asking you. It's just on by default. So what we do is we come back and tell you, here's your v4 address, and also it's got these v6 link locals, and here's the ports open on them too. So the way we do is we do a link local discovery first, multi-protocol ping on the FFO201 address. We get a bunch of error replies, things like that. And then we map those back based on the MAC address to the ARP request that we do on v4. And then we then treat them as the same asset. So even though you're only scanning IPv4 with runZero, we're giving you the full v6 response for link local anyways, because we think it's a crime not to show it. And just too many people make it an optional feature and don't realize it's there. It's really cool to see what services come back that are on v6, but not on v4. There's all these storage appliances where you get back like, okay, port 22 and 443 on v4, but like Redis is wide open on v6.
Is there an easy query inside runZero for services on v6 but not v4?
No, we need to come up with a way to do that, like some way to show like the overlap on it. But that's been a back of minds. You can kind of eyeball it right now. You can go look at the services and say, sort on v4 or sort on IP address to show v6 only. But it's hard to kind of do like that diff today.
Hey, we got a question in chat. So M. Cohen's asking, HD, what are some of your best practices for reducing attack surface on a per device basis or perspective?
I mean, it's kind of the standard, right? Don't put anything on it, turn it off, get as close to off as you can get. And, that means not overloading a single machine with lots of different tools and agents. It just kind of reducing the exposure as much as you possibly can. And then, folks like to use segmentation for it, but, segmentation works only as long as everything's perfect. So there's all kinds of fancy, like one underrepresented security feature is the client isolation of modern access points. Like, I don't think a lot of people realize how savage the world was in public Wi-Fi before isolation became the standard. But previously, you just go to DEF CON and collect passwords all day long, and you didn't really have to work for it. They just showed up. And nowadays, it effectively puts every wireless client onto their own separate little mini VLAN in a lot of ways, prevents crosstalk. So that type of per device VLANing is helpful.
You just caught Leonard Koopman's attention. He's working on Enzyme, right? Wi-Fi security. Leonard jumped in right at that moment. Yeah. So what does IPv6 do for this problem? Obviously IPv6 is necessary because of IP exhaustion and all that good stuff. But it also adds a whole bunch of new questions, right? Like to how routing works and how exposure works, because now gone will be the days of the security afforded by NAT. So does this make the problem, exponentially worse, somewhat worse, not worse at all? What are your thoughts there? Should we avoid IPv6? Obviously that's unavoidable, but what are your thoughts?
It's helpful for privacy. I mean, you see things like moving target defense techniques where folks will just because every individual host of a v6 network is allocated a /64, which is the equivalent to the entire IPv4 internet squared. So you get the internet times internet number of IPs for every individual host. So you can't go scan and find all those hosts by any means, but it does allow you to do some kind of cool privacy things. Like every connection you make, you can then pick a different source IP for, or it's driving a lot of the privacy features of iPhone. So every time you pop on a network, you do the random MAC and a privacy v6 address, and that's a way to avoid some of the tracking and tracing. When it comes down to server infrastructure, though, it doesn't really help anybody much because you have to find the servers in the first place. So they're in DNS, they're in a neighbor table, there's somewhere else you can find them, or someone like John or Shodan has sniffed all your v6 addresses because he runs his rogue IPv6 NTP pool. I don't know how many folks are familiar with that, but it's hilarious. So it got on the news a few years back, and it's still actively going. But Shodan runs an entire pool of IPv6 NTP servers for the express purpose of doxing everyone's IPv6 servers. So whenever you query the ntppool.org with one of your v6 enabled machines, it eventually ricochets into one of his NTP pools. He now knows about your IP, and then immediately scans it with Shodan. And so you find all these
a lot of flack for that. I thought he stopped after he got a bunch of flack for that one, but
I don't think he stopped. I mean, it's a great technique.
He stopped flack and kept going. Well played.
Is awesome. As far as I can tell, it's still doing it. I think it's great. I mean, it's a great technique. I don't see any reason to not do it.
I've had chats with folks that are like, oh yeah, we found Shodan scanning our perimeter and we just blocked it. I'm like, okay, cool. So you blocked Shodan, right? You didn't block the kinds of people. Yeah, you didn't block the kinds of people that are going to abuse the exposed services. You just stuck a Band-Aid where what you needed was a tourniquet. Yeah.
I love chatting with the Gray Noise folks are a lot of fun too to chat with about all the stuff they see. So they see all the, who are the good scanners, who are the bad scanners, who are the crazy ones, right? Just sending random garbage out there.
Love them because they also kind of stand by the similar principle, like runZero having a free tier. Lima Charlie, we do the same thing, and I love that Gray Noise makes so much of their content free and available, because at the end of the day, man, I think that's what pushes us all forward, right? Is not having these incredibly high boundaries. Like you can't even like explore our product without talking to a sales team and committing to a year and yada yada yada. So thank you for making that kind of part of the ethos of runZero, because you love to see it. That's freaking awesome. Well, folks, we're down to the last couple of minutes, so before we run out of time, I just want to throw out a couple quick updates to you all. For those of you heading to Black Hat DEF CON, know that the Lima Charlie is going to be there in force. So please come and say hello. Would love to see a bunch of you guys out there. And one other cool reminder, so we are bringing a new CTF to DEF CON this year. It will be very similar to CTFs that you know us by from the past. We're going to have a ton of fun with that. More news is coming next week about that, so follow Lima Charlie socials. And I'm thinking probably about Wednesday, we hope to have some announcements posted, so you're going to know a lot more come middle of next week. Also, for those of you that know, Lima Charlie runs an annual event called Mission Control. It's going to be in Arlington, Virginia in October. If you want to learn more about Mission Control, come and hang out with our team, listen to some really cool security, engineering, orchestration, automation, all that kind of stuff talks. It's not a vendor con. It is a practitioner con. I just dropped a link in chat if you want to learn more. Would love to see you guys out there in Virginia in October as well. Otherwise, as you all know, be sure to join the Slack, slack.limacharlie.io. Every week we send out a really cool Defender Friday shirt. HD, yours is already in the mail, sir. That's where, for those of you that come in week after week, that's where we announce the winner of a Defender Friday shirt. So be sure to join the Slack. Otherwise, I mean, if there's no other questions or final comments, HD, we can probably wrap this up. We definitely covered more than a half hour's worth of topic here.
I appreciate it. Now I feel bad not wearing the Lima Charlie shirts in the wash, but next time. So
no worries at all. Awesome, folks. Well, have a fantastic rest of your Friday, a great weekend, and we will see you all next week. Take care. Thanks, HD.